everybody. I am Travis the Maker. You can find me on Instagram and on Twitter at these two accounts, Travis the Maker, the lack of E on Twitter, and at Instagram, Travis the Maker. Tonight, I want to build a 2D plotter. I've already done some steps and I've done some research in the past, but I'll try and catch everyone up to speed. So, this is my portfolio. I've made a lot of attempts at plotters in the past. Specifically, where are they? Here we go. So, this is a thing I built once. That's about as far as it got. Some tracks and things to move along. Joined a makerspace and got access to a laser cutter, and so got to play around with that a little bit. Wrote some Python code to kind of convert images to burns in wood. This is one of my first plotters that sort of actually worked, powered by Arduino with Kinects and rubber bands and such, but fell apart about there. And then just some output from that Python code I mentioned. So I recently purchased an Ender 5 3D printer and wanted to, let's not click that, let's go on images. Got one of these and wanted to see if it would be possible to turn it into a 2D plotter. So if we jump over to Instagram at this point, I've kind of demonstrated with this video that it is possible. So to start, I want to show you how I got to this point of making this physical little apparatus there for connecting the pen, and then the code that I wrote and how I figured that out. And the next steps, I'll be writing some Python code to do that, to actually kind of do some more interesting things than drawing a square and an X. So yeah, so how I started, basically what I did is in my notebook, I came up to, let's see if we can look at the printer head. There are no good photos. See if I can zoom in on this guy. Yeah, that should work. So basically what I did, it doesn't work either. So I noticed that on the Ender 5, there is a screw here and a screw here, and this is also a terrible photo. So something that's, oh man, this is a little rough. Just go back to the actual printer. Any one of these. Okay. So if we look in the Ender 5, there is a screw here and a screw here that attaches the fan to the rest of the system. And I figured that I could make a little 3D printed part that would use these two screws and then kind of sit in here. And so what I did is I measured, this is a very dirty page at this point, but I did some measurements basically with calipers. So if you don't own calipers for any adventure, I highly recommend them. This is like a $20 purchase off of Amazon. I have a slightly better photo on Instagram. So as you can see, I started to sketch out kind of those two screws that I mentioned and a rough outline of all the different bits to make a print. And so if I switch between SolidWorks, and I'll start, so I did these in 4 iterations. Alright, so if we start with print 1, this was my first print. It's very thin, and it's just basically a conversion of all those dimensions that I sketched out on paper. I accidentally opened the STLs and not the SolidWorks parts, so let's come back and do that. Alright, let's try that again. So, okay. Oh man. Okay, so this is the first iteration. Just basically one layer thick, and then I could take that, print it out, and attach it to my printer to see if I got the placement of all these different bits correctly. So if you'll notice, this hole and that hole are what you'll see on the printer there, and then kind of outlined the fan and this little screw up here to kind of avoid that. So in the future, I'll try and actually model these real time. So I printed this guy out. I realized some of these measurements were off, and I moved on to part 2. Yeah. Is this really part 2? Yeah. Okay. So part 2, you can kind of see it's jumped a little bit ahead. There's a little bit of material sticking out over here as well, which you can see right over here. So if we come back to the image, this little bit right here, I didn't want to get in the way of my print, so I made a little hole for that, which is what you see. Oh man, wrong one. What you see here, and then I took my calipers, measured my pen, and figured I could stick it down this tube. So this is kind of just the pen that I measured, and if I take the rubber bits off, I measured the diameter of this right here, and then that could just slot right in here. And my reasoning was that I could use a binder clip and put on either side and it would keep the pen snug. Turns out I didn't actually need that. I made this hole a little bit too tight and the pen actually snaps right in there. And then I added these little triangles right here to make a little bit more rigidity, because I was a little nervous that this little bit right here was not going to be strong enough to hold the pen in place. And so I printed again, but it was a bit too flexible. This little bit over here could wobble way too much and the pen moved around. And so I decided to give part 3 a try and added a whole bunch more reinforcements. I was kind of limited by this gap right here between those two little bits right here, but only in 2 dimensions. I realized I could actually add some material in the 3rd dimension, which is this wall you see here, and it was much more rigid. I also realized that I added too much space in here, so I went back and refined that, and these holes are too small, so I made it slightly bigger. So each iteration I was adding kind of slight improvements to everything, and then printed this guy out. It's almost perfect, and then I snapped this a little bit off. So I enlarged this diameter just a little bit for my final print, and this is what I ended up with. Now this guy is super rigid and works pretty well. So yeah, so this is what I ended up with. This is a way to attach the pen. If you'll notice in this video, where's the video? Right at the beginning, I have to press the pen down myself, and so I think as a next step of something else that I'll plot at a later date is a way for the device to automatically maybe 3D print a little part that can press this down like that and then come back down at the end, press back up. Cool. And then so we have the code, or sorry, we have the piece to hold the pen in place, and now kind of the basics for a 2D plotter, and now we want to jump into the code. So I initially basically, now we're kind of stepping back after the fact, is I went in and I just took some notes on what G-code is, and I found those on RepRap. I found this helpful little wiki. And so I read through, kind of skimmed it because there's a lot here. And I kind of looked for, I knew words that I wanted to see, like I know home makes the printer reset itself in the X, Y, and Z axis to go back to 0, 0, 0. I knew that I wanted to be able to move things around and stuff like that. And so I searched through here, and so I found like home is code G28, and I thought move might be another thing, and here's the move command. It's either G0 or G1. I noticed that, let's see, is my printer on? Cool. So, next step, let's expand the video a little bit. Cool. And if we take this, hang with me for a sec. Alright, so we're going to hold that there. And so I have Octopi installed. Highly recommend it for doing 3D printing. We bring this over on the side. It's always a little finicky to get up and running. Let's see if we can set this down. Cool. All right. It's being finicky, so we are going to power it off and power it back on. Everything's a little bit of trial and error in this game of making. All right, so let's give it a sec to start itself back up. This IP address is specific to my machine, so if you set up Octopi, you'll want your own IP address. All right, you can do it. Come on. Cool. Okay. So, whoop, mark as red and ignore. So I noticed that in here, not in here, in terminal, this gives you a little way to send codes and try them out. And so back over, close the Ender 5 documentation. Let's open it back up. All right, so in here, I wanted to try out these codes and just kind of see how they work. So first one, let's connect to the printer first. Cool. All right, let's clear it out. So let's see, G0, what does that do? Looks like it's received the command, and nothing's happening, because that's the move command. Let's try the home command. And I know this from the documentation. I'm currently looking at my notes. So G28, you can see is slowly moving the printer home. And I wonder about other things, like what if we want to try G0? If we go back and look at the documentation for G0, we can see that there's a way to move, and there's a bit above about this being the position to move to the x-axis, position to move to the y-axis, position to move to the z-axis. So what if we go G0, let's go, I know my printer is 200 by 200 by 230, so if I go half of that, 230 divided by 2, 115, should take everything right into the middle. Cool. At this point, I think there's not really anything else that I wanted to do. That I knew of commands that'd be helpful. I think it's really just those two commands. A way to zero everything and then go from there as a point of reference. I noticed that if you don't home everything before starting to send the G0 commands, it actually assumes that wherever the printer head currently is 0. So G28 at the start of every script is a great way to start with things. So yeah, so the last bit to catch everyone up to speed is I went over to VS Code and I wrote this little script. And it was painful and uncomfortable to do, and so I'd like to find a way to automate this all with Python. But I noticed that, so yeah, this is, printer's almost done. Let's bring it back up here. Cool. Let's bring it back down and get me back out of the way. All right, so I noticed that in G code, basically the things I mentioned, G28 and G0 is really all I used. And that's how I ended up with this video that runs over here on my Instagram. And the general idea is, I totally have no idea what I'm doing, to be honest. So you can add comments with a little semicolon, and it's basically just line by line. So kind of similar to what I did right in here, G28, we go home. And for some reason I can't send commands. I'm not sure what is happening. Ah, this is fun and new. Temperature is not changing. I just can't send anything anymore. Interesting. Okay, who knows? If I refresh, do I get control back? Or maybe it's just stopped working for some weird reason. In which case, I should probably figure this out. Okay, for some reason the IP works, but that doesn't work anymore. Fun, fun. Anyway, G28 can send that. It's already home, so that's fine. Okay, so G28 sends it home. G0 wanted to add a little bit of space and time, so basically what happens is you go to home and 0, or the Z direction is 0, and so you hit Z0 and then you hit Z10 and it drops it down 10 millimeters, and that gives me time to press kind of the pen that's attached down. It's a very manual process at this point. I like to do something better, but for now this works. And then if you ignore one of the coordinates or 2 of the coordinates or 3 of the coordinates, it'll just go to the coordinates you specify. So if you specify x40 and y90, it'll go to there, but it'll remain at Z10. And at that point, I want to drop the pen to the surface, which is kind of what we can see in here. So if we start it, we can start this video again. So right now, it's dropping down, and that's the Z10. And now it's moving to x40, y90, and then it's dropping down in the Z direction and tracing that square, which is this first set of directions, lifting the pen back up, drawing one of the diagonals, and then drawing the other diagonal. And then, yeah, so that's how this code works. And that is catching everyone up to speed. And so now it is time to write some Python. Pardon, I have not actually... I generally do all my work on a MacBook. I don't think I have Python. I don't. Interesting. It's been a long time since I've developed on Windows. Alright, so bear with me while I install Python on Windows. Alright, what do we want? What do we want? Stable releases. Xpeed installer. Okay, yes. 3.8. Alright, let's go. Alright, so while that happens, I want to open up... I'm really hard at visualizing things. So I want to draw... Alright, is this done? Setup was successful. Okay, chances I get Python. No. Oh, heck. Yeah, it's been a very long time since I've developed on Windows. Well, hold with me while I... Alright, so can I just make a Python file? Let's save. does that command work? Code. So that works. Cool. Okay. Oop. So if we do, all right, stop talking. This is just going to open the store again. Interesting. Let's try it again. Nope, nothing. I don't even know if any of these commands work, which is not, yeah, because that's a Mac term. Alright, so if I open, alright, can I open in terminal? Oh my god, leave me alone. Actually, I'll just close you for now. Cool. Run Python file terminal. Cool, okay, so that gets me. I'd go away. Are you still open? No, you're closed. Okay, cool. Alright, so we have Python running. Back to Paint. So with Paint, I want to think about the two dimensions because I struggle with this. So if we go with this, 0 and 0. If we switch back over here, before we get into code, let's think about how we're going to do this. So if we go G0 and we want to go to Z, no, we go to the max X. If we look at the printer, max X is over here. So this 200, 0. And now we want to go to x0, y200, which should diagonally move across the bed, which it is. So this is 0, 200, which would make this 200, 200. Cool. Okay, so now this is our coordinate system. And so we want to draw letters like this, the letter A. This looks like we're going to have to start over here and then move that way. Maybe let's start with the numbers to make that simpler. So say it's the number 8. And I was thinking as I was going to do these that they should all fit into a very simple kind of thinking how we want to draw the letter number 8. So can maybe draw the outline for imagining this is the printer head. Lift up, come back down, and then draw that. And then you have the number 8. And then 1 would start. So we always have to specify a corner, it feels like. So 1, 2 would start up there. 3 would probably go down. And then lift up and finish. 4 would do that. Lift up and then finish. 5, 6, 7, 8 would lift up and finish. 9, down, and 0. Cool. So we go with monospace fonts. And monospace fonts just mean that they all have equal widths. So whatever we specify this as, if say it's X, this will also be X. This will also be X. We can also think of that kind of is in terms of like a 7-segment display. Very simply, you can only turn on any of these parts, and that's kind of what I've represented here. You can see that even I kept a 1 as a monospace. So learning exercise, I think we can start with just doing very simple monospace stuff. I want to write a Python script that can take in a bunch of letters, print them out, and know when to go to new lines. And I think as the last bit, I think all of these, I want these fonts to be scalable. So maybe make them as the smallest possible representation, smallest size possible. Think of them kind of as vector graphics. For those that don't know what vector graphics are, they're basically math based images. So if you go to Photoshop real quick, so you have vector and raster. And raster images, let's open up a 500. Let's come in here and let's see. Let's get the paintbrush out. So say you paint something, and you're like, okay, let's go something more realistic. You're like, hey, let's go full hardness. Cool. All right, now we can make a smiley face. So good example. Okay, so there you have your smiley face. It looks pretty good at this resolution. Sorry. All right, so nice smiley face. But what if we wanted to make it bigger? So what if we said, let's make, instead of this canvas being 1,000 pixels squared, let's make it 3,000. And you want to make a bigger smiley. So you come in here, you drag your smiley all bigger, then you'll notice it starts to blur along the edges. And so that's what a raster image is. And it's kind of not the approach we want to take. We want these fonts to be infinitely scalable. So there's another way called vectors, and I know they're in here somewhere. Yeah, no. There we go. Okay. So this is an example of a vector. Ooh, if I can do this right. Let's try that again. Let's do something more simple. Cool. Okay, let's do a triangle. And ooh, I have no idea how to interact with these. That is the pen tool. I thought that would be a separate layer. Let's see. So we can fill. Okay, so if we fill 100%. Cool. Okay. So this is now, don't even know what that triangle up there is, but so we have this triangle, and if we keep zooming, it just keeps being sharp. If we come out here and we super enlarge it, I guess let's fill this guy. No idea what I'm doing. Okay. Well, this is weird. Put him back. What if I put him back in there? Nope. Okay. Well, anyway, the point I'm trying to make is that you can infinitely, yeah, it's just whatever. You can infinitely scroll in on this guy and it'll continue to be sharp, and that's because math is what, basically there's equations like y equals mx plus b that connects all these together and lets you zoom in forever. So similarly, if I define these as kind of like a, over here, this top corner is like 0, 0, and down here is, let's see, if we're going to follow this, it would start at 200, 0, and it would go to 200, 200. Make a really squished in 1, and then you could multiply it by some number and it'd expand outward. So let's go write some code. And maybe this will all make a little bit more sense. Cool. All right, so I want to think about this in terms of, I think each letter being a variable, a series of steps. So if we go like letter A, and then we want it each to be a series of codes. I have no idea what I'm doing. Let's think on this. Okay, so, or sorry, not the letter A. Better name character. and then we'll have character 2. Maybe we'll start with character 1 and 0. So 1's a straight line, and that's pretty simple, and 0 is just a rectangle. So if we assume the most simple shape, this is interesting. Okay. Cool. So I want to draw some way to draw that line. So that line would start at, how about we do this? If we assume, let's go with the number 0 first, because that gets us kind of in 2 dimensions, because 1 is just a straight line. So if we say that this is 0 and this is 1, actually, let's go even simpler. 0.5. And this down here is also 0, 0. This would be 0, 1. Let's avoid the parens and not make it too complicated. And this would be 0.5, 1. This is kind of the grid in which we're working. And the reason I went with 1 is that you can kind of multiply it up to make it bigger or make it smaller. So if you multiplied every number in here, so say you wanted to make this twice as big. If you multiplied everything in here, this would stay 0, 0. This would become 1. So this would be 1, 0. This out here would be 1, 2. This right here would be 0, 2. And you've kind of now scaled it up by 2. Okay, so this makes sense. So we start with characters 0. We can say that G0 is going to be X0, Y0. And at the beginning, and kind of what I had found in that G code that I'd shared, no idea if I even saved that, so I'm going to grab it from where I know I shared it. So hold me 1 second while I go and grab it off of a friend that I shared it with. Cool. So, all right. This is the code that I found that works, and after going home, I want to go down to Z10, and then Z2 is the height that it hits the surface at. So I want to begin every command with going to Z2, and then finishing with going back up to Z10. And this will probably start to feel a little repetitive until we'll come back and refactor in a little bit. Okay, so over to 0, 0, and then we probably want to go down to X0, Y1, and then go left to X 0.5. And actually, I'm remembering, I'm not sure if my printer supports floats. So what if we try, so I want to check that. So an integer is like 5, and then a float is like 5.5. So a float just means that there is a decimal place and there's numbers after it. Integer means it's a full number and there are no decimal places. And if I want to use decimal places, I should probably check out if I can actually support that. So if I go to, first it's home. Cool. All right, let's see if I can rotate the monitor to show what's happening in the background. Cool. All right. So now G0, and then maybe let's move to 50.5, and hopefully it doesn't freak out. Sweet. We can use floats. Let's send it back home, and let's keep coding. All right, so now it's over to X 0.5, Y1, go to X 0.5, Y0. Okay, so at this point we go here, and then we go there, and then we go there, and we go there, and then we're going to go back home to finish out the circle. X0, Y0. And that, at that point, should have everything in there. Make this a little more legible, just add some spaces, and I also found that adding extra spaces doesn't do anything. So if we come back here and go over here, Well, we're already home, so it doesn't matter. Let's verify since we're already home. Always better to test things more than less. And that, I think, moved it. Was not looking. All right. Cool. Okay. So let's home it. All right. So, and I know we can add comments. So pen down, pen up. Cool. So that feels like some code that makes sense. Just sanity check real quick. Let's throw it in here. And let's actually attach my pen so we can see this all happening. So can you all see my pen in the background? Yep. Okay, cool. So I can come in here, snap that in, and it's a little loose, but it'll do for now. Maybe we can actually try out the clamps that I mentioned earlier. And I just happen to have a ton of clamps because, you know, as you do. All right, I think, let's see, I think this is the right size clamp. Cool. That seems pretty sturdy. Sweet. All right. So, I know the next step that I want to do is I actually want to scale these up because currently it's going to do boop and be really small. So I want to turn these into functions. So this is a little bit first bit of refactor because I know these are already too small and I want to be able to pass integers in there and scale these up. So let's go scale factor. By default, they'll be 1, so they'll just be super small. And we'll just return. And this will become a format string. So if f means you can basically take this scale factor and insert it in here. So the zeros don't matter, but we want to scale the z up by 2. So we can do 2 times scale factor. So scale factor is 1 by default. It should still give us 2. We come in here and wrap this 0.5 in a scale factor. We can now scale up that. Add 1 times scale factor. Okay, almost the testing phase. And anything that is 0 doesn't matter. Because anything that's 1 also doesn't need to be multiplied by the scale factor, but whatever. Okay. And actually, whoops, we don't want the scale factor on the z because we don't need to blow that up to make it larger. Okay, so say we want to make this 100 times larger. So that would make this 0, 100, 50, 100, 50, 0. So if we do that, and then we want to print that out and see what we get. So we can copy it into our G-code tool and see what happens. So save that. I want to turn on autosave because I usually like that on a computer. Run in the terminal, and we get this code. Cool. So if we copy it here, and we save that as and G-code is the extension for all G-code, and that's all G-code is. I can save it, and I can come over to Octoprint, and I can just upload it as a file to Octoprint. I can't get my tabs right. Cool. All right, so go to desktop, grab the letter of G-code. Cool. This prints very fast. I'm usually used to these things since it's 3D printing. I'm used to this heating up and then taking forever. But that's kind of not what we're dealing with, and it's just going to go very quick instructions. So it should ideally come out to about here. Let's see. That should be about 100, 100. That should be the letter O. So let's see what we got. Gotta find it. We're not connected. We're not connected. Cool. Letter O. What is happening? Okay, now we can print. So we hit print, and it is drawing the letter O. Oh, that is so cool. Oh man, that is so cool. Awesome. Alright, so then if we want to make it 200, scaled up to 200, and then we ran that again. Grab this code. So everything is now scaled up by 200. Let's upload that code again. Print it, and so now it should come all the way out to here. Sweet. All right. So the last bit. Okay, so we have our character. I guess it's not the last bit, because we have to do 9 more characters, but okay. Let's make another character. I feel like if we do another character, oh, this is going to get complicated. So what I'm seeing is that this will happily print everything in absolutes. So like, if I wanted to print 2 character zeros next to each other, and I just called this code twice, so if we call this code twice, so character 0, if we then run that, what you'll notice is that the x and y starts are the same, which means it's just going to draw it right on top of each other, which means nothing in the x and y, everything needs a starting point, a starting x and a starting y from which to draw the dimensions. Interesting. So we're going to need to probably do that next. So I think the goal currently is how can we print 0 and 1 alongside each other. And the reason I want to do this is because in programming we typically, I don't want to solve all the problems in just character 0. By doing character 1, it'll start to highlight some things that I've potentially done wrong in character 0. And then as you start to go out to all the other numbers, you'll start to notice patterns. And so you won't necessarily notice patterns when you do things once. And then I also want to expand this out to do them side by side. And that'll highlight some other issues. So I think at this point, I don't want to keep working on character 0. I want to do character 1 and then print 0 alongside 1 spaced out. Yeah, so let's create character 1. So we go back to paint. Character 1 will. So I think first thought is I want them all to be kind of start within this very simple to understand grid and then add some kind of bit to position them so relative to each other. So this will be absolute positioning, and then we'll add in the relative positioning later. I realize that relative and absolute might actually be CSS properties that not everyone's familiar with. So basing everything around 0, 0 would be absolute positioning. So 0.5, or actually let's go down here. 0.5, 1 is absolutely 0.5, 1 away from 0, 0. That's absolute. It's absolutely positioned. Whereas if I wanted to print another letter 1 here relative to the previous one, you would then say 1 is relative to 0 in some way. So relatively speaking, 1 is to the left of 0. Hopefully that makes sense. So let's draw character 1. So character 1, pen's going to move to, and kind of in the system down here, I'm going to follow that. So 1's along the left side. We could also put 1 on the right side. So with 1 on the left side, we are going to go, I'm going to start this again just to make life easier. And already I can see some kind of patterns, as I was saying, producing themselves or making themselves apparent. So this seems like every single time I start a character, I want to go up and down. And maybe that code doesn't need to live here, but I don't know where the pattern's going yet, so I'm not going to deal with that. So first, let's go. And actually, I'm realizing another thing. When we go to the starting point, that's when we want the pen to go down. So, oh gosh. Okay, so long since I've used Windows shortcuts. Okay, so we take this line and swap it here. What that means is it's going to go to the starting point, then it's going to drop the pen, and then it's going to start drawing. We don't want it to be dragging the pen as it moves to x0, y0. So maybe we can't actually do anything about that line. We'll see. Okay, so we want to go to x0.5, y0. And if we follow that bit, just repeat this bit of code. And I'm noticing another trend here, is that we really only have 4 points currently. So with those 4 points, we can make, actually just 2 of the numbers. But if we had a point here and a point here, that would be able to give us places to draw all 10 numbers instead of having to write out this whole thing. So instead of like x0, y0, we could say like, kind of similar actually, I think how 7 segment had it. I guess not quite the same because they kind of do it in the middle. But we could say that, we could say this is A, B, C, D, E, and F. I'm kind of just choosing letters at random here. But you could say that 0, you start at A, and you go to C, and then you go to D, and then you go to F. And 1, you'd start at F, and you'd go to D. Program is all about layers of abstraction, and we're not going to go all the way into that, but that's, you know, one such layer of abstraction that you can make. Cool. And now I'm actually curious. I'm going to try and do that. Okay. So those would also have to be functions, I believe. A, B, C, D, E, and F. I'm trying to think how this would expand after when we want to start doing 7 segment with the alphabet. And I wonder, you know, what does? Because this is really the motivation. This is where we're going to go tonight, alphabet. All right, so if we look at this, oh, that's kind of cheating. K is cheating. M is cheating. Because M is wider, so M is not a monospace. You notice every letter in the first row is the same width, but M is different. This is not actually a 7 segment display font. What do they do for M here? Oh, that's weird. Interesting. So let's see, how many of these actually make sense? Exclamation point makes sense. Quotes, that's questionable. Questionable. Ooh, these are rough. I mean, this is what you get when you only have access to 7 LEDs that can light up. So these all make sense. Interesting. All right. B, C, D, E, F, G. Oh, that's wild looking. You know, let's do this. This actually feels doable so long as we can define primitives that are each of the lines that make up a segment. And so if we could say that, like, let's try that. So we could do these as functions as well. So actually, if we say we have 7 functions, draw A, B, C, D, E, F, and G, we can combine those together with this bit here, and we can get the full alphabet. Cool. So we're learning things. We're learning things. Let's comment this out for now. So if we do def, say line A, and we want to be able to pass the scale factor around. All right. So A would start at 0, 0 and go to 0.5. All right, so let's uncomment this so we can steal all the code. So let's for each of these, let's make them atomic units. So we want to go Z2, draw the pen down, end it. Oops. Pen down, and with pen up. All right, so line A will be go from x0, z0 to x 0.5. Ooh, that's a y. Y0. And then multiply this, scale factor, and that's our line A. All right, so cool. Let's complete F and E, since those are the ones that make up 1, or they're not the ones that make up 1. 1 is on the right side. Ooh, 1's on the right side. So we should do B and C next. Make sure we can draw the number 1 and then keep going. Okay, so number 1 goes from 0, 0, and this would become 0. Ooh. Ooh. 0.5. That's not that. So this over here would be 0, 0.5. Cool, cool. Okay, so line B, go from 0, 0 to 0.5, y0. Whoop. Cool. And then line C would go from cool. All right, so whoop. Okay. All right, so then delete this because we're learning things. Uncomment this out. All right. Whoop. All right, so we want to draw lines B and C, and it doesn't really matter what order we do them in, but let's see how this goes. Line B, line C. And I'm realizing that each of these return strings, and we want to print at some point. So if we just do output equals that, and then output plus equals that, output plus equals that, and if we pass in the scale factor, so by default it'll be 1, and 1 will just be passed in there, so we don't actually need these anymore. Scale factor should probably be passed in per letter. You always want to have a main function. So main at this point will just print cool. And then we'll call it. And this should give us everything we need. Let's make this size 200. So if that's size 200, scale factor for character 1 is going to be 200, which means for line B, it's going to start at 0, 0 and go down 100, and then it's going to start at 100 and go down to 200, which should give us the max size of the printing bed, and should just draw a straight line down. So we do that, and we run that again. Copy this in, and oh, sick. Okay. Nope, that's incorrect. It just drew, it went down and then back up. Oh, am I off by a factor? 0.1. Whoops. Okay, let's try that again. Okay, this looks better. Alright, so now just go down, and then the bed should come up. It's a little weird looking. Ugh, oh well. Okay. I'm realizing that I should probably print for now, just D28. Home it as we start. We run that again. It doesn't print. Oh, it does. It's over there. Because we have all this spacing over here. The joy of multi-line printing in Python is that all this space gets printed. That doesn't. But I don't think G-code seems to give a crap about white space. So if we just home and then print and then home again, and I believe this should just actually work. Right. What we got? So it's just interesting. Okay, cool. We have a function. This feels good, actually. Okay, so we have some primitives. Let's finish ABC. All right, so if we come back here, I will actually be right back. Boop. All right, cool. I'm back. All right, so character ones. All right, so we're going to finish these lines up. So we have D, A, B, C, D, E, F, G. Cool. All right. So A, B, and C are done. D is going to be the bottom one. So that's going to go from x0 there to x 0.5 times scale factor y is going to remain the same. It's almost like you could do another set of primitives, which are just these, to specify the 6 points. And from the 6 points, 1, 2, 3, 4, 5, 6, you make the 1, 2, 3, 4, 5, 6, 7 lines. But we're not going to do that, because that's effort. All right, line E starts from this one. And then line E goes up to, oh gosh, math, 0.5, 0.5. Could we make this just a little more human readable? I guess that would be confusing. Let's just leave that. Okay. Line F picks up where this one left off, and then goes to 0.50. Line G goes down the middle, so that goes from x0, 0.5, finishes over at there. And then D, no, wait, am I done? Okay, so to test this, A, B, C, D. So can we do character 8? I think is the next step. So 0 is line A, B, nope, I gotta figure out these keyboard shortcuts. Nope, not that one. Ha! Some Windows, Shift Alt, multiply the line. So A, I know it starts here, so let's go B, C, D, B, C, D, E, F, and then go vertically across A, G, D. A, G, oh my gosh. Just told you what this is and I can't remember. Boop, let's try this again. No. There we go, okay. Let's try this again, sorry. B, C, D, E, F, A, G, D. Cool. So that should be the letter C, or the number, that's actually 8. It must be a good way to test everything. So we do 8. Run that again. This is the code to make 8. Save that. Let's upload. That file name's lie, whatever. Alright, what we got? This is going to be slow, especially with the lift up and lift down. I think at some point we can stop doing that and only drop down. This requires some thought. Oh, that's totally incorrect. It's drawing diagonals right now. Why is it drawing diagonals for these? For G and D and A, I think it just drew diagonals. So A should be Or no, maybe it's not. Oh, maybe it did lift up, because it does come back up. Okay, so I think it's about the point where I want to get out a pen and test this all, but how would we do that? So we got the number 8. We don't want such a large scale factor, so maybe 200 millimeters is too large. So if we bring out the ruler, look at it correctly, we probably want something that's 20 millimeters tall. And we'll stick a little sticky note at the origin. Save that. Run that. Cool. Oop, missed the G. Alright. Save that. Upload that. Just grab a trusty sticky note. Throw it in. 0. Alright, so actually I know on this code that I want it to start at Z10. I want it to drop down a little bit so I have time to click my pen as I talked about earlier in the video. So at this point I'm just going to go back and manually edit. G0, Z10. Upload that. Okay, let's see what happens. So it lifts up, drop it down. Oh, heck no. Oh my god, that's terrible. Okay. Oh hell. That was fun. That was bad. Z2 is just not the number we want. Okay. Because I don't feel like editing this in 10 places. When I had 2 heights, so the height at which the pen is contacting the surface, just kind of think of as Z2, and the height that it's traveling, Z10. So if we highlight all of these, hopefully Control D on Windows will highlight all of them, all instances of that Z2. And we can call that draw height. And if we do that here as well, that is the travel height. Cool. And then if we come up where we declare our variables, we say scale height, travel height, draw height, and now do the same here, scale height, travel height, draw height, and define it. So originally it was 2, sorry, travel height was 10, draw height was 2. Cool. These need to be factored out and should not be set on a per character level for this. So let's declare them as like this. Should not have defined values, at least for now. And then scale factor, travel height, draw height. Cool. Cool. So I want to go back to Octoprint real quick to figure out the best heights for things. If we go to terminal, so Man, I kind of don't recommend this. This feels dumb. Let's move the Z down. I cannot unclick the pen if you smush it too far into the bed, so safety warning. Be careful of zeroing out your pen because your pen's dragging into your bed. My bed's made of glass, and I also have 2 more replacement beds. And I have replacement pens. So take that as you will. Okay, so let's see. If we want to see... Z2 was too aggressive, and that was causing it to drag along the bed. So if we drop it down a little more... Still too far away. So we're going to go... I know that we can go... Let's suppress these temperature warnings. You can go less than a millimeter. Interesting. So I guess this is me doing the process of calibrating. Do it 6. Cool. Place that there. I think I can go more. Ooh. Oh, I'm feeling ambitious. Okay. Go. And now let's see if we can drag it along. Nope. Does not draw anything out. So let's go lower. Where do we go with the Z? We ended on 3.8. 3. Oops. I think I'm actually going the wrong way. Too far. Too far. That might be it. It might be 3.6. Almost. Nope. Let's drop it down a little more. Goes here. 3.4. Doesn't want to draw. Where do we end on? Can we always scroll this? Ah, scroll to end. Okay. Auto scroll. Ooh, let's go. There we go. Okay, cool. So it does not want to draw with his pen. Ooh, that just snapped off. Don't even know if the pen is currently interesting. Okay, let's try this again. So if we bring it down closer, it's going the wrong way. I was actually, by increasing Z, I was taking it further away. Okay, that's sort of something. Oh, did I type that wrong? Oh, it's already there. Okay, cool. All right. So our Z height was Z3. So our draw height is 3. It doesn't need to go up that high because even bringing it to 4 is already too much. All right. This should be good. This should be... And actually, we can now go and replace these with F strings. Cool. So we'll start, it'll be homed. So actually, if we duplicate this line, this will give us time to take pad on. Okay. So the code should be in there now. A little aggressive with the 20, but oh well. Okay. Let's see what we got. This post-it might already be absolutely ruined. That was all wrong. Let's see. Okay, so the values are too small. Did I pass the wrong? The scale factor's wrong. Trial and error. That's about what I do. Okay, I'm gonna get a new post-it note. Okay, I can't even stick it under there right now, so let's start printing, and then I'll slide it under. Oh, that's terrible. Alright, so we got the top right corner and the bottom left corner, but nothing else. So I guess my calibrations were not that good, or jamming the pen in the printer bed wasn't the best idea. So let's move it down so we can click this pen off. And now that I'm thinking about it, we should end here and take pen off. Cool. I don't know. Let's make it lower. Print again. Okay. So it's going to home and then drop down so I can turn the pen on. And it's going to come in and still fail to draw. Boo. Okay. So I said Z3, Z2.9. Okay. Oh, if you press the up arrow, you can repeat your previous commands. Cool. Okay, so maybe 2.7 is our number. Run this again. Save it. Upload it. At this point, I'm going to hold down my sticky. Once it starts zeroing. Cool. Nope, doesn't like that either. Man. Totally going to ruin this printing bed. Oh yeah. Not noticeable. Okay. This worked so well the other day. All right, I think. What do I know? Making sure the bed level is definitely a thing. And I know that I've done test prints to make sure that all the corners of the bed are level, which if you're 3D printing, you should be leveling your beds. So I don't think that's the issue because I've been printing just fine today. But I also haven't printed a leveler test in a while. Let's make this super exaggerated so I know the code works and I come back and troubleshoot this later. So if I set the travel height to like an absurd amount, so it's very clear what's happening when it's traveling. Leave the pen unchecked this time. Alright, what do we got? Just gonna do a mental check here and make sure this all makes sense. So it homes, perfect. Goes up to its crazy high height to click the pen, but we're not gonna do that. Alright, so it's home. Yeah, this looks good. Nope, that's wrong. Alright, so I think there's something wrong with A, G, and D. Draw, travel, they all start with draw and end with travel. So it's not that. And none of these have... Interesting. Okay, so drawing... Alright, so let's review. A goes from 0, 0 to 0 0.50. B goes from 0, 0 to 0, 0.5. C goes from 0, 0.5 to 0, 1. D goes from... Oh, D is totally wrong. Is it wrong? Yep, it's totally wrong. Okay, so this... No. Okay, D. D goes from 0, 1 to 0 0.51. Okay, I guess that makes sense. E goes from same x decreasing y. F goes from same x decreasing y. G goes 0, 0 0.5 to 0 0.5, 0 0.5. And then it should be B, C, D, E, F, A, G, D. This feels correct. Scale factor, travel height, draw height. Scale factor, travel height, draw height. Yeah. It's the same all the way through. Okay. What does it draw, though? What does it draw? I know... Ho-hum. Okay. Let's try this one more time. Oh, come on. Nope, it's like so close. Okay. Let's just... Also, my table's wobbly because I just moved it to record this video. It's not usually like that. Okay. Cool. Oh, did I bork the G code? Doesn't want to print it. Interesting. So all looks fine. I have no idea what's happening. Okay. So it went diagonally across from here to there for some reason. So that would be, it would start at, if we look at the multipliers, by 20. So 10, 10. And go to 10, 0. Only one of these, doing a mental check in my head. Is lifting up not make sense? What is happening? Oh man, fun to troubleshoot while trying to record a video. What is happening? Let's try and do the character 1. And let's save that. Oops, what happened? Character 1. Line B is missing 2. Ah, whoops. Cool. A little bit simpler of code to reason about. So this should be... Let's try and get my little piece of paper back that kept this all flat. Which I don't even see where that is. Let's stick some sticky notes under there for now. We can come back to this later. Cool. It's a little better. Alright. Cool. So... Okay. That is number 1. Interesting. Okay. 1 works fine. Let's try and get all the numbers in there. So... Who knows? Who knows? And I actually want to do some refactoring. So if we call lines primitives, once we build up our primitives, we don't need them anymore. This makes it a little bit more Pythonic. 2 line breaks. And then characters from primitives import star. And our characters will go in there. And then here we should have, access to character 1 and 8. And import star, we should have access to lines A, B, C, D, all those. Cool. So 1. Let's make this 2. So 2 will consist of 1, 2, 3, 4, 5 lines. 1, 2, 3, 4, 5 lines, and it will go A, B, G, E, D. I feel some refactoring coming, but this is fine for now. 2. So 3 will be A, B, G, C, D, which is 5. A, B, G, C. Okay, let's stop there as we think about the next steps. Okay, so we can do 1, 2, 3, and 8. Not 8, there's a bug in there. We'll come back to that. Cool. Alright, so if we have 1, 2, and 3, and now we want to do positioning. And if we think of positioning, scroll over a little bit. Let's get our little, oh, we already have a printout. Okay, so we think of positioning. Let's do this in 2 colors. So we have a grid like this. And if we change to black, this right here will be half of our scale factor. And this will be 1 scale factor. And we do the number 1, number 2. Oh gosh, that's a terrible 2. So is that 2, 3, 4. And if we do them exactly, so if we dramatize, 1 would go there, 2 would go there, and that doesn't look good. So we'll probably want some kind of spacing. And that could be maybe just thinking about this, maybe 1/10 of the scale factor. Because why not? So for each letter, it would increase. The starting point would be right here. So 1 would be a starting point of here, and then it would go over and draw 1. And then it add a 1/10 of spacing, and then draw the next letter. So I think we need a way to go from strings to printing out characters, and a way to add spacing. So I think we need a map. And I've done this in JavaScript, not in Python in a while. Do character map. So no, we're not doing that yet. Too ambitious. This would be character 1. We replicate, and our dictionary only supports these things yet. Cool. Let me test. I think that's how you do it. Okay, so if we want to make this into a function, So for let's take an input string. For char, an input string. I'm so confused. Oh man. Is that how you do it? No. Let me bring that command up that I had in here. Here. What if I just do this? Okay, cool. So I like to test things out. Okay, so it's going to iterate on each letter. And if we do my dict, this is just totally arbitrary, but just to test that this actually does. If we come back up here, print my dict of char. So it should print out 1, 2, 3. Sweet. Okay, so that is going to do what I expect. So input string is going to be 1, 2, 3. It's time to variable name. Boop-a-doo. So we want to grab the function at that char and then execute it and print that. Cool. So don't need this anymore. So that, okay, so let's see. So that'll print us to the home. I wonder if this will work. So I know this is not going to fully work. I'm going to leave that terminal open so we can experiment some more. Can't up arrow in here. If we copy this, so we can execute Python over here. Cool. All right. Sweet. So that gives us 1. What? Oh, this is hard to read. Okay. Let's print. Just make it easier to read. These will be comments, so these will not be readable in G code, but they will be human legible. Okay, so 1 is this, 2 is that, 3 is that. So everything's working. Cool. But we'll get back to the original issue that everything is kind of stacked on top of each other. So we want to do X start, Y start. So if we now X start, Y start, which will pass those to our characters, and we know, just do that repetitive text thing, highlight these all. Oop, that's incorrect. Nope, that's also repetitive. Okay, how about this? Cool, there we go. So X start, Y start. So come here. Whoop. I can't see what's happening. Alright, so basically what I'm doing is I'm using a keyboard shortcut where if you highlight text, it'll then highlight instances of the same text. So if I do, I know this is the closing function with the parens, which will only match the things that are highlighted here. So I can just hit that 10 more times. Bring my cursor here, do X start, Y start, and then finally my primitives. X start, Y start. Okay. Almost done, almost done. Okay, so oh, this math's gonna get annoying. Okay. So A will start at So anywhere at 0 is just going to be x start. Actually, we can do that little highlight trick I mentioned. Anywhere where we have x0, that can just become x start. Likewise, anywhere we have y0, that can be y start. Whoop, I forgot the y. Okay. And then this, anywhere else that doesn't have x start or y start, will just need to be added. So this becomes x start plus, this will be y start plus, I'm repeating myself in the next line. Change that to y. Okay, that wasn't that bad. Cool. Still going. Okay. X start. This needs to be y. Cool. Awesome. So, okay, almost there. So, interesting. So if we want to print a string, this is going to receive the characters 1, then 2, then 3. So we want to print left to right. But currently, it's going right to left if we want to increment. So we're going to actually have to decrement. So our x start kind of on here is actually going to be on the left side of the printer. The y start can actually be 0. And we want to minus each time by the scale factor plus the character spacing. The character spacing was decided to be, I guess we can make that a different variable. Oh, we will also need vertical spacing for new lines. Let's leave that be for now. X spacing is scale factor. I think in the drawing we had said 1/10, so 1/10 the scale factor. Let's add that in now. Scale factor will also be divided by 10. Cool. So the first character can start at x start, y start, which is fine. And then after this, x start will equal, we will decrease by the x spacing. And since we're not going to a new line, we're just going one strip of characters across. We'll get to new lines. It's going to be a bit more programmatically complicated. X start minus x spacing minus scale factor. And it needs to be 0.5 because the scale factor is half. So it's going to show if this character is 20 millimeters high, it's 10 millimeters wide. And then we want the gaps to be 1/10 of 20 millimeters. And so that is the math that we end up with here. So the spacing right here is half of the x spacing. No. Yes. Sorry, I'm going to say that again. So this is half of the scale factor, which is 20. So this is going to be 10. So this is going to be 10. So it's going to print a whole character, and then it's going to add a little bit of spacing. And we're going to slowly move our way across left to right. Let's see what happens. 1, 2, and 3. Okay. Let's see what happens. And this, if I can get this to work, will probably be the stopping point for tonight. All right, let's see what happens. Fingers crossed. Oh gosh. Oh yeah, I forgot the fact that the pen is, it's just printing over empty space. So the pen is actually offset from where the nozzle is. So all these dimensions actually assume that we're printing with a nozzle, but we're not. So the X start is not 200, it's actually slightly less. So if we measure the distance between where the nozzle is supposed to be, oh my gosh, I can't, there we go, is roughly 50 centimeters less. So the X start should actually be 150. Cool. And it's printing something. Who knows? Who even knows what the fuck it's doing right now? Apologize for cursing. Let's cancel this print. Ah, man. Okay. I said cancel, not home yourself. Cool. Okay. So I'm now reading G code. So at no point should the Y's get really small, which they seem to do. So in 2, the third step in 2, 1, 2, 3, G is weird. So what is G doing? G is going from X start, Y start. Ahaha! I knew that was going to catch me. Alright. I knew that was going to bite me in the ass, putting the X start in the wrong place. But, whoops. Okay, so these should now all be slightly less than 200, which they are. Let's print. Oh my gosh. Okay. We're going to try moving the Y down a little bit as well. Let's start 20 millimeters down. It feels like something. It's like almost there. Still some weird geometrical stuff happening. Should also decrease the overly exaggerated. This looks like hieroglyphics. Oh my god. Alright, so it looks, it's something. It's like the number 3 and the number 2 are clearly visible. There's something that's causing it as it travels to do part of the 3 that is making it drag. But those are gaps between letters, and 1 is like almost there. It's something about, okay, so when the 1 ends, it wants to drag to the start of the 2. Interesting. Is there something that's... Are floats a lie? That wouldn't make any sense. So the 3 should start out... If the 3 starts out with the A, starts out with an A, something is causing from the... It's not lifting up. Oh, haha, haha, I see it. I mentioned this earlier and then somehow didn't fix it. You shouldn't be traveling before you're at your starting point. So you should go to your starting point and then you should change your draw height. I mentioned it. I said it was going to bite me in the ass. Here we are. Cool, cool. Okay, so now we have our characters, which should be good. This should be the code we need. I don't want to make this so stinking obvious, so let's set this to a nicer number. Run this again. I feel like re-energized to keep going. They say you should always stop on a high note. Maybe just stop when you're finished. Okay. So, oh, let's panic. Let's rush. Let's boop. Grab a clean sticky. Ooh. Oh, I totally broke my... No, I didn't break my pen. Oh my god, it's the number 2. Ah, this is awesome. Alright, we got a little drift. That's okay. That's okay. But we got the numbers 1 and 2. Ah, that's awesome. Ah, that's so awesome. Oh, man. Okay. On that note, I'm going to take a quick break. And we will... What will we do next? What do I want to do next? I want to output this automatically to this file so I don't have to keep creating the print's just all around. Print's bad. Don't use print. Write to file. Be smart. Maybe strip out the tabs, make it look a little prettier. All right, so let's write up below. To do. Let's move the tabs to the output. Let's write to file. Finish numbers. Itch my ear. Cool. You know, I should listen to my own advice. I'm going to stop on a high note tonight. I got 1 and 2 drawn out. It looks good. We have some to-dos for tomorrow. So, let's finish this off. Do we have Git on this computer? We don't. Okay. Do. Let's Git commit this all. Let's go 64-bit. This is what I get for doing things on my gaming computer. What do we need to do? Cool. I don't even know what that does. Git from the command line. Yes. Sure. Oh, I hope I don't regret this. Oh, let's do this another screen. Verify with my phone. Cool. All right, so I've made so many 2D plotter. (2016, 2017). I think there's another one. I swear this time I figured out 2D plotting. Even repo is it? It's one of these. So I think this then comes in at the 4th time that I've attempted to do 2D plotting. Whatever. It's called 2D plotting. It's here, finally. Alright, so hopefully... No. Source account. Man, I really don't know any of this on Windows. Nope. Sure. Is move a command? Move is not. Victor. Ah, gosh. Oh, missing operand. Victor. 2D plotting. Cool. Oh, no. Okay. Did I miss anything? No. Oh, pie cache, whatever. Cool. Should I edit on Mac? That should be close enough. Okay. All right, that is up. Personal command, git add. Let's not enter that information here. Okay, we back. Does command paste not work? It does. Okay. Origin master. Oop. Oh, SSH keys. Damn it. Okay. Well, switch screen for this. Sorry y'all can't see any of this, but not put my SSH keys up on the screen, you know? Alright. Almost done, my dudes. Cool. Okay. So, bring this up here. CD back to desktop. Yeah. Ugh. Final type it out. Upstream origin master. Sick. Sick, sick, sick. All right. Thank you all for coming. I guess I will probably post this on like Twitch and YouTube, and feel free to ask me questions. I'd love to answer more. I don't know what the heck I'm doing first night on here. So thank you to those that might eventually end up watching this, and I'll see you next time. Peace out.